As a final topic of today, let me discuss about the gravity effect as I promised. So the question we're gonna ask is, can we ignore gravity? And the answer is yes, but there is condition for kilonewton scale loading problems. And let's consider why. So suppose that you have some 30 kilonewton external loading, and if you look at 30 kilonewton, it's 30,000 newton, and it's correspond to around the weight of 3,000 kilogram or 3 tons. Okay, so when you see like a kilonewton problem, it's typically like a ton or 0.1 ton kind of weight. Okay, so the weight of 30 kilonewton, 30 kilogram mass. However, if you consider the mass of the rod BC and boom AB that we considered, and you can see that for kilonewton scale problem, to satisfy the allowable stress guideline, the diameter would be like a 20 millimeter or 30 millimeter, that scale. So for 20 millimeter diameter scale, which is 0.02 meter, and the length of 1 meter or 1000 millimeter, then if you consider the density of steel, it's around 7,800 kilogram per cubic meter. Yeah, so please note that the density of steel is much larger than the density of water, which is 1 ton per cubic meter or 1000 kilogram per cubic meter. Now if you consider the volume of rod BC, you have to do pi r squared multiplied by L, and it gives you pi 10 to the negative 4 cubic meter, and the mass is, you have to multiply the density with the volume. The mass is 2.45 kilogram. Okay, so hence the contribution to the loading due to the gravity is the weight of 2 kilogram, and compared to 30 kilonewton problem, it's like like less than 0.1%. Okay, even though instead of 30 kilonewton you have a kilonewton problem, the contribution is 1%. Okay, so of course there's gonna be contribution of the gravity due to its own mass. However, you can see that if somebody gives you like a kilonewton problem, the contribution of the self-weight will be 1%. If it's 10 kilonewton problem, the contribution is around 0.1%. So you can ignore these kind of conditions. And you can also see why in your textbook there is no just a Newton problem. You can see that most problem will have a kilonewton scale. The reason is, even though the textbook assumes that gravity is not important, the textbook writers is careful enough to choose the external force scale so that much larger so that the force from this external loading is much larger than the self-weight force. Okay, so please note that for like a kilonewton scale problem in our textbook, we can ignore gravity effect. And please also note that this is why there is no 10 Newton or 1 Newton problems in our textbook. Please remember that back in freshman physics and high school physics problem, you might have seen like a 1 Newton and 10 Newton loadings. However, we are now in the engineering society, and in engineering they want to make the problem as real as possible, and that's why they consider kilonewton scale problem where you can ignore the gravity. Okay, if one started to include the gravity in structural analysis, the problem gets much more complex, and that will be the topic of a much advanced class. Okay, so with that, let me finish the lecture 2.